This video is part 1 for September 12th, September 13th, Monday and Tuesday. What we're still looking at sine and cosine. We're still graphing that, and we're still transforming sine and cosine. This is the last transformation we're going to look at. Excuse me. To kind of recap, what we looked at is how the function shifts up or down if we were to add or subtract a value inside our function, left or right if we were to add or subtract inside of our function. We also looked at amplitude change or reflection if we multiply our parent function by a value. Now we're looking at what if we multiply by x by a value, how does that change our function? So let's start by looking at the function sine of 2x. Now I'm going to pre-prescribe the values that we're going to look at. Starting at 0, and then really we're going to count by pi over 4. In class, the one we did together was sine of 3 pi over 4. I'm going to go ahead and call this 2 over 1 because we're going to be dealing with fractions, multiplying. So sine of 2 over 1 times, plug this into our function. And if we multiply, 2 times 3 pi would give us 6 pi. 1 times 4 would give us 4. And then we can simplify this fraction, 6 pi over 4. 2 goes into 6 evenly, 2 goes into 4 evenly. And so this simplifies to 3 pi over 2. And what we can do is either look at the graph of sine, or we can look at the unit circle. Either way, sine of 3 pi over 2 is going to be -1. That should be a -1 right there. And so our ordered pair is 3 pi over 4, comma, -1. Now I would recommend pausing the video right now, trying to do the next 4 on your own. I'm not going to go through the next 4, I'm just going to go ahead and give us the ordered pair. So if you want to pause it, that's fine. I would actually recommend it. But if we were to plug in these values into our function, those are what we would get. So we need to be careful with scaling. Our largest x value is pi, and then we can fill it in. So this would be pi over 2, pi over 4, 3 pi over 4. And we can go in the negative direction. I'm not going to do that just because of where the ordered pairs are. And what we can do is graph the parent function, like, 1, -1. Now we can draw the parent function. Now we need to be careful here. Sine starts at 0, 0, starts, quote unquote, 0, 0. And it reaches the value of 1, not at pi over 4, but at pi over 2. The parent function reaches 1 at pi over 2, and then it reaches 0 again at pi. So it's going to look a little different than previous graphs because the scaling is different. And if we, alright, I'm going to go ahead and do this. I'm just going to do these two because it'll kind of show us more of that function. So that's our parent function. Now let's graph the points that we have, 0, 0, pi over 4 and 1, pi over 2 and 0, 3 pi over 4 and -1, pi and 0. And so this function looks like this. Excuse me. And so in class we talked about what's happening, what is going on with our transformed function. And what we discovered is if this is our parent function, if this were to continue, the period would be 2 pi. However, on our new transformed function, our period now becomes pi. So I'm going to write this here. Our period, I'm going to leave some space there, equals pi. Also, in each class, we talked about why the graph, what we do here should correspond to what we do here. And what people noticed is, well, the period of sine, if we're just looking at sine, is 2 pi. We multiplied x by 2, and now it's pi. So what must be happening is dividing by 2. 2 pi divided by 2 is just pi. Or we can think of this as multiplication. So we're really dividing by 2. Whatever value x is being multiplied by, we're really dividing. But we could also say division is multiplication by the reciprocal. Either way is fine. The multiplication, the reason I wrote this as a fraction is to write this as times the reciprocal. That's going to come in handy moving forward. I just want to make sure we see that. Okay. So the period change. The period happens if we multiply our variable in parentheses. So sine is not our variable, our x is our variable. We multiplied x by a value, so our period would change based off of that value. For example, if we had cosine, I'm just going to do the periods here. Well, I can probably graph these two. Period here would be 2 pi. We're multiplying x by 4, so we divide by 4. And then we can simplify that to be pi over 2. Okay. But the reason I was writing fractions is we're dealing with a fraction here. X is being multiplied by 1/3. Let's put a 1 there. X is being multiplied by 1/3. So really what's happening is this is 2 pi divided by 1/3, or 2 pi divided by 1/3, or because we know if we divide fractions, we're really multiplying by the reciprocal. So I'm going to do it up here. So our period, if we can think about multiplying by the reciprocal because we're really dividing, is 2 pi times 1/3. The reciprocal will be 3/1, 6 pi. I wanted to show this because this form doesn't look very friendly. This form, dividing fractions, doesn't look very friendly. This more likely is more friendly. So we can already think, we know we need to divide, but the way we divide fractions is we take the reciprocal. That's key. If we can know that, that's huge. Now, let's graph them. So let's look at cosine. Now, my period here is 2 pi over 2. So I'm going to come out here to pi over 2. And I'm still going to make 3 tick marks in between. So like 4 tick marks in total. Between pi over 2 and 0, or if I take a half of pi over 2, that would be pi over 4. Between pi over 4 and 0 would be pi over 8. That's not on a unit circle, so I'm just going to leave that. And then we're still looking at cosine. Largest value is 1, smallest value is -1. Now that we have this, we can just look at the parent function for cosine and basically mirror it, but on a different scale because our new period is pi over 2. So what we know about cosine is it quote-unquote starts at 0. It's going to go down here on our parent function. This value is pi over 2. It's different now because our scaling changed because our period is different. But it's still going to hit 0 here. It's going to go down to -1 at pi over 4. Back up to 0 there. And then hit 1 at pi over 2. So again, it looks very similar to our parent function. The only thing that's changing is our period, and so our scaling changes. Alright, let's look at this one. So let's say this is 6 pi, because that's our period. This is our period. Between 6 pi and 0 would be 3 pi. 3 pi and 0 would be 3 pi over 2. We're cutting that in half. And then this would be 9 pi over 2. If you want any questions on 9 pi over 2, please ask. 1, -1. We know sine starts at 0, so let's start there. Now, similar thing. On sine, this, on our parent function, this was just pi over 2. Now we have 3 pi over 2. But if it was just pi over 2, if we cover that up and it was just pi over 2 and just sine, it would go up to 1. Same thing here. It still goes up to 1. 0. -1. 0. So our function actually looks the exact same. The period changed. And if we were on the same scale, I'm just going to do this real quick. If we were on the same scale, let's say this is 2 pi, 4 pi, 6 pi, what this would end up looking like, our parent function would look something like that from 0 to 2 pi. But our actual function here is very much stretched out. That would be 3 pi. We just don't see it as stretched out because our scaling is different. So that's a key observation we need to make and apply moving forward. Now, the next page is a very critical piece to this, so please, if you have questions on this, ask. We're going to review this on Wednesday the 14th or Thursday the 15th. If you have questions, ask. But on the next video, we're going to go over how do we do it if we have two values in the parentheses.